So this is a solution for the question that I asked you to have a go at. So in step 1 we underline key points. So it's a cardboard box with a square base. We're given its capacity, so that means we know that its volume is 216,000 centimetres cubed. And we're asked to find the minimum amount of cardboard. So the amount of cardboard is talking about surface area. So we want to minimise the surface area. So drawing a quick sketch of a cuboid, because we know it's a square base, we can have x for the length and the width, and the height we'll call h. That's going to enable us to write expressions for the volume and the surface area. The volume we can put equal to 216,000, that's going to equal x squared times h. Area, we've got 2 lots of the base and the top, and 4 lots of the face x times h going around the side. Now we know that we want to minimise the surface area in this particular question, so we're going to have to differentiate and find the stationary point of the area, but we can see here that at the moment that area is in terms of 2 variables, x and h, which is why we're going to need this expression for the volume here to substitute to get rid of that h in the expression for the area. So that's what we're going to be doing in our step 3. So this is what step 3 does. We want to minimise the area, but it must be in terms of 1 variable only. So we're going to eliminate h from the expression for the area by substituting from h from the expression for volume. So rearrange the expression for volume to get h, and then we're going to substitute that in here. And then we're going to simplify. So we get an expression for area, and this is in terms of x only. So now we're going to differentiate that expression for area. So first of all, we need to write that fraction as x to the minus 1, and then we can differentiate to get dA by dx. That stationary point dA by dx is 0, so put dA by dx equal to 0 and solve the equation. So to solve that equation, first of all, we're going to multiply 3 by x squared to get, that's going to give us a cubic, which we can rearrange in cube root, and we find that at the stationary point, at either the maximum or the minimum area, we need x equal to 60 centimetres. Now this time we've asked to find the minimum area, so we need to justify a minimum, so we should have differentiated again to get your second derivative, and then substitute x is 60, which gives us a second derivative, d2a by dx squared is equal to 12, so that should actually be, that's actually greater than 0, isn't it? So d2a by dx squared is greater than 0, and that tells us that a is indeed a minimum of x equals 60. So we can then finally find the dimensions of cardboard for the minimum amount. Well, we know x is 60, so all we need to do now is find h. So we can substitute x into our volume expression, and we get h is 60 as well. So we therefore know that for the minimum amount of cardboard is when the dimensions are 60 by 60 by 60 centimetres, which is actually when the box is a cube. So there is a worksheet of problems on Teams for you to have a go at. Remember, follow the steps, but the key points: draw a diagram, write at a stationary point dy by dx equals 0, and always test if you have indeed found a maximum or minimum using the second derivative. The extension is Pure Year 1 book, exercise 12K, question 7 onwards.